Good afternoon, everyone, and welcome to your Slit Education webinar. Hope you're happy to be back at work. If you're not happy to be back at work, you're probably happy to be out of the house for a change. Speaking to quite a lot of you over the last couple of weeks, and I think most people are back. I know a few people will still be shielding at home, but we're gradually getting back to normality. I wasn't sure how the turnout would be for this webinar, as people are back now and seem quite busy, mainly with the COVID testing, but we've got a good turnout. Just over 70 people signed up for this webinar, and I can't see exactly how many people are logged on right now, but I'm guessing it'll be around 50. Today we're looking at Inspire Physics. Inspire is a range of exclusive physics equipment to us. It's about 2 years old, or just over 2 years old, and was designed by ex-physics teachers. It's been specifically tailored to UK GCSE and A-level syllabus. This webinar will be a circus of pre-recorded experiments showing what the equipment can do. So below is a list of the video demonstrations we'll be watching today. I'm going to play them in this order. I've put what the product's called, followed by the stock code, some of the subject areas it can be used to teach, and at the end says how long the video is. They're all quite short videos. The longest one's 8.5 minutes. And right at the bottom you have the laser ray kit, which has no time at the end because there isn't a video, but I do have the equipment at home, and I think after the compact ripple tank video we'll have a little break. I'll turn my camera on and I'll give a demonstration of that then. All these videos can be found on YouTube or via our website. I'll show you how you can play them via our website at some point during this as well. As all this equipment was made by ex-physics teachers, it also comes with really good manuals, teaching technician notes, and other useful things. Again, I'll show you, you can find them on our website as we continue. So the first, and before I forget, if you do have any questions, please use the chat function. Our technical support ladies, I don't think they're on here right now, but they will be here shortly. They're going to monitor the chat function and reply to any questions. I won't be able to see
now, Gary. I think you can hear us. I'm not sure
right.
if everyone else can, but yeah, we can see the chat to send messages.
Okay.
If anyone does send any.
No, thanks for letting me know, Kat. Now, see, while I'm in full screen, I can't see exactly who's on and what the chat function is. That's why Donna and Kat will be looking after that section. And at the end, if there's any questions we can't answer, we'll take your details and your technical sales manager will be in contact with an answer. So I will now switch my share screen and play you your first video. The first video is on light gates. Sorry, I've just realized I forgot to add sound. So we will do it again.
To the Inspire range. Inspire light gates and Timing Pro software offer facilities for a full range of dynamics experiments. The primary light gate connects wirelessly with PCs and smart devices. It has an internal rechargeable battery which powers the secondary light gate and the G-by-freefall solenoid via link wires. The light gates can be used with the law of motion kit, with a linear air track, or G-by-freefall apparatus. Timing Pro software captures events and calculates velocity and acceleration as required. The software can also capture the motion of a pendulum or the frequency of a vibrating string. The law of motion kit, exploring Newton's second law. The light gates are supported above the track at measured positions. The trolley is pulled by a falling mass. The trolley's acceleration is captured by the light gates and calculated by the software. Repeating the experiment with different falling masses provides data to establish the relationship between force and acceleration. That is Newton's second law. A single run has been captured here, showing the interrupt times for the two gates and the calculated acceleration. When different masses are used, the acceleration is different. A number of results can be used graphically to verify Newton's second law. Using the special clamps, the light gates may be attached to the linear air track. All the familiar air track experiments can be captured with the light gates and Timing Pro software. On the primary light gate, the secondary light gate link wire connects here. The secondary light gate has two sockets, allowing secondary light gates to be daisy chained. In this way, one primary and a number of secondary gates can be used to capture motion in great detail. Pendulum investigation. A swinging pendulum interrupts the light gate. Here, we're interested in the pendulum's timing rather than velocity or acceleration. Look at the software. We see a regular series of interruptions. The table to the right of the graph shows the period of the pendulum is constant. Repeating the experiment for different lengths of pendulum supports investigation of the relationship between the period T and the length L of the pendulum. The light gates and software have sophisticated facilities for determining G by free fall. A simple method is to drop a fence mask through the primary light gate. Acceleration is captured and calculated from a series of interruptions. We can zoom in on the graph and we can look at the value of G. The G by free fall apparatus provides alignment and precise positioning of the light gates. The solenoid at the top of the apparatus connects to the primary light gate. The solenoid holds and drops a steel ball or steel dowel through the two light gates. The positions of the light gates are entered in the Timing Pro software. The ball is attached to the solenoid and the indicator LED turns on. The solenoid only draws power when the ball or dowel is attached. Each light gate has a pointer to make positioning precise. Clicking Start Stop triggers the solenoid to drop the ball and the light gates capture the event. Data is captured for each drop, building up data tables of light gate interruptions and calculating values of G, which are displayed in a bar graph and also to the right of the graph. Light gates are one member of the Inspire family of products.
Yes, they are one member of many. I'll just show you where you can find the video and also some documents. This is our main website. I'll click on Inspire Lightgate. For any product, when you scroll down, you might get some extra tabs. So under Lightgate, we have video here. If I press play, that plays the same video we were just watching on YouTube. Accessories and range shows things you might be interested in if you're using this product. For example, the freefall stand you saw in the video is something you'd need to buy separately. So if you want to do G by freefall with these light gates, you might want to purchase them. Range will show other things such as the secondary light gates, the picket fence that you might use as well. documents, as I mentioned earlier, they're really good manuals for all this Inspire equipment. I'm not going to show you it in depth, but just to give you an idea. Your labels, it will show you how to do some of the main practicals as well. It will go into details about the software, which is very easy to use, I have to say. And if I skip to the bottom, here it shows you where it can be used in the syllabus. So we've got Edexcel Core Practical 1, determining the acceleration of a freely falling object. And you've got Core Practical 2, mechanics, AQA, what it can be used for, and I think OCR at the bottom. Yeah, OCR as well. We will go straight onto our second video now, which is again to do with G by freefall or projectile motions. It's the Bluetooth timing ball. I think it's our shortest video as well.
The timing ball is a great way to measure G by free fall. It can also be used for time of flight investigations. The timing ball is switched on by pressing the wake up button. The blue LED flashes. Communication with Timing Pro software is established by clicking on Connect. The blue LED becomes steady. Communication via Bluetooth means that data can be captured on PCs, tablets and smartphones using the appropriate Timing Pro app. The ball is armed for an experiment by pressing the wake up button again. A green LED shows the ball is ready to record an event. A time is recorded. The pointer accessory makes it easy to drop the ball by a repeated measured height. G is calculated for each drop and a bar graph is built up. A result in error can be deleted. In the advanced section, this statistical function shows the spread of results and the mean value of G. In the time of flight experiment, the ball can be thrown vertically and caught, or thrown at an angle and caught. It is important to throw and catch at the same level. From the times of flight, the software calculates the maximum height and plots a point for each throw on the graph. The timing ball gives long battery life between charges and switches itself off after 90 seconds of inactivity. A second version of the timing ball communicates with Timing Pro on PCs and smart devices. It also has a time display for immediate readout. The timing ball is one member of the Inspire family of products.
So that was the timing ball. So when I had my training on that, what I found the best was actually the projectiles when you're throwing it and watching the curve. I'm just going to check that we can see the chat function, because I've had a message from Kat to say she hasn't had any questions yet, which is quite strange. Conversation. Yeah, I'm not sure if anyone's tried to send us any questions. In fact, I think we have a couple of TSMs on the line, so could you just send a quick message in just to see if we can see it and get anything? If not, we may not have any questions for the webinar and we'll need to take care of them afterwards. If you could email us. Okay, we'll move straight on to our third video while we're checking that. This video is the Dynamics car. It's the longest video of them all, about 8.5 minutes, but it's a very good product, so it's worth watching.
The Inspire Dynamics cars have a full range of accessories for dynamics experiments. Elastic bumpers, inelastic Velcro bumpers, hook attachments, an explosion bumper and hammer, additional masses for either car, large hooks for the track end plate, a pulley attachment for Newton's second law, masses, hanger and cotton cord, a large bumper and double-sided tape for crumple zone experiments, elastic bands and cord for oscillations, a linear track and a curve track. Each car has spring-loaded, low-friction wheels, magnets for attaching accessories such as bumpers and hooks. The primary car is marked with P and the secondary with S. The pegs are locations for additional masses. The primary car communicates wirelessly with a PC using Bluetooth. Infrared sensors provide communication between the cars. Elastic bumpers are fitted to both cars and to the end plates of the track. Both cars are switched on. The blue LEDs flash. The cars are connected to Timing Pro software. Click on Start Stop to begin the experiment. The blue LEDs become steady. Push the primary car so it collides with the secondary car. Data is plotted in red and blue on the default graphs in real time. Primary data has red headings, secondary data has blue. Data before and after collision can be deleted, or the user can zoom in on the useful part of the graph. Select graphs by clicking on the icons. We can remove displacement, we can remove acceleration, and select momentum and energy. Using summation, we can show that momentum is conserved and energy is conserved. Using the large bumper, aluminium foil and double-sided tape, a crumple zone can be made. This is intended to absorb some of the energy of a collision. Look at the data, in particular the energy graph. Zoom in on the collision. Use summation to see whether energy was conserved. Clearly, it is not. The cursor can be used to find instantaneous values of energy before and after the collision. Approximately half the primary car's energy was absorbed by the crumple zone. This standard experiment uses the primary car alone to investigate potential and kinetic energy on an inclined plane. The linear track has a special block to raise one end. The track has a simple clinometer built in. The angle is entered in the software. The car is connected to the software. Clicking Start Stop begins the experiment. The user is prompted to move the car from the bottom to the top of the track, giving it some initial potential energy. Releasing the car allows it to roll down the slope, losing potential energy and gaining kinetic energy. We can see velocity increasing, and we can see two plots for energy. Looking more closely, we can see kinetic energy increasing and potential energy decreasing. Using the summation function, we can see that energy is conserved. Timing Pro software has a dedicated procedure for Newton's second law. A falling mass makes the primary car accelerate. Varying that mass and the mass of the car provides data to verify Newton's law. The primary car is used alone for this experiment. Connect the car to the PC, click Start Stop, then release the car from one end of the track. From the software, it is possible to measure the period of the oscillation. Run the experiment again with the car fully loaded with additional masses. Measure the period of the oscillation again. How does this relate to the motion of a simple pendulum? Oscillations can also be studied on the linear track. The primary car is used alone. 2 strings of elastic bands are required and the hook attachments at the end of the track. Both chains of elastic bands are fixed to the car. With the car connected to the software, click Start Stop and displace the car either to the left or the right. Measure the period of oscillation from the software. Then repeat the experiment with the car loaded with additional masses. The oscillation appears slower. The software will tell you how much slower. Why is this different from the changing mass of a pendulum? Dynamics cars are one member of the Inspire family of products.
Okay, I'm sorry, the reason that wasn't in full screen at the start of the video is I was trying to play around with this live event to see if I could get the chat function working properly, because there is a chat function. At the moment it's just me, Donna and Kat that can speak to each other. If you do have any questions, you can contact your area sales manager, which could be me or it could be one of about 6 or 7 people. It will be the person who emailed you and told you about this webinar. Or if you want to go to Donna and Kat direct, that is a technical support email address for them. So we will respond to all your questions and answer any you have. I'm sorry the chat function isn't working today. You need to find out who your area sales manager is. If you turn over the front page of your catalogue, there's a map of the UK, a list of our names, email addresses and phone numbers, so you should be able to figure out who to contact there. We will go on to our next video, which I think is Inspire Ripple Tank. Again, for all the products I'm showing you, there is a video on our website along with documentation.
Inspire compact ripple tanks, available in 2 versions, are self-contained for ease of use and simple storage. Accessories are included, to demonstrate and explore a wide range of wave phenomena. Wave generation and strobe frequency can be synchronized or independently varied. Both are displayed continuously. The frequency range is adjustable from 1 to 250 Hz for the advanced ripple tank, and from 50 to 175 Hz for the simple tank. The advanced ripple tank has amplitude control in 5 steps and brightness control also in 5 steps. Wave patterns are displayed on the built-in screen, which can be removed for upward projection. The small volume of water used makes this ripple tank easier to set up and minimises the risk of spills. The control panel is a membrane keypad which is resistant to spills. Inspire ripple tanks are powered by a low voltage power supply. Open the accessory compartment, select a dipper. This is a single point dipper. Place the dipper in the vibration stem. Add around 120 ml of clean water to the tank. Make sure the dipper is touching the surface. Switch on vibration and strobe. Change mode to independent. Changing the vibration or strobe frequency now gives the travelling wave view. A single point dipper gives circular waves. A double point dipper gives 2 identical sets of circular waves, which meet and produce an interference pattern. The plane wave dipper produces plane waves. Placing a straight barrier in the tank at an angle shows reflection of the waves. A curved barrier can show reflection and focusing of the waves, which is a model of a concave mirror's behaviour. With this special barrier, we can model the Young's double slit experiment. Plane waves arrive at 2 gaps or slits and produce 2 sets of circular waves, which interfere in the space beyond the barriers. This is a model of the behaviour of laser light arriving at a double slit. Placing 2 barriers in the tank shows how plane waves arriving at a gap produce circular waves. The ripple tank will also demonstrate refraction at a lens. This requires careful adjustment of the water level to achieve good results. Waves are slowed down as they pass over the lens. Camera mode provides display via a USB camera on a PC or on a whiteboard for full class use. The ripple tank is one member of the Inspire family of products.
So that was the Inspire ripple tank, which is one of my favourite products from the Inspire range. I'm just going to show you on the website. There are 2 different ripple tanks. One is the simple and one is the advanced. The price difference is about £30, and I have always recommended that people go for the advanced. The reason being is the extras you get for the £30 are definitely worth it. Just that camera button alone is worth it, because you can get a nice clear image on the interactive whiteboard or take a video on your phone. And the other buttons you get as an extra are the vibration, amplitude, and the strobe intensity, which are always quite fun to play around with because you do get better images. As I showed you before the light gate, I'll just demonstrate where you can find everything here. The video you just saw, it will be under the video tab. Accessories, it will show you a camera and a camera stand, but you can use what you have already. Range, that's the other option. Documents. Again, you've got a really thorough manual, 10 pages long. Everything's labelled. It's really neat and tidy the way all the accessories fit into this ripple tank as well, by the way. And again, I won't go for everything, I'll skip to the bottom. It's how to use camera mode. Yeah. Right, I'll stop sharing. Hi everyone, so yeah, we're about halfway through the videos we're going to be looking at, so I thought we'll take a look at the laser ray kit, which I mentioned before. There's no video for this, which is why I'm showing it live. What you get with this kit is you get a briefcase like this. There are 14 lenses in there, which are all labelled. The two gaps you can see are for the laser ray box and the power supply. You get 7 pictures. First one I already have on the board, which is a picture of the human eye. Then you get a camera, Galilean telescope, a Keplerian telescope, spherical aberration, Hartle circle, and a periscope. No lenses are required for the periscope. You would just use mirrors, which are labelled where you would use them. But all of these pictures, I'll try and get you to see. Yeah, so we'll have what lens to use and where to put it. That is a number 1 just here for the camera. I have this up on a magnetic whiteboard. This is one of the accessories you can buy. If you have a magnetic whiteboard already, you won't need it. It's not actually part of the kit. Everything's magnetic, so our ray box magnetic, these pictures are magnetic. Turn it on. Human eye, I think, is always the best one to show, because kids always understand glasses, nearsightedness and short-sightedness. So lens 1, 2, or 3 can be used, and then 4 and 5 would be the glasses to correct. So if we start with this one, that's someone with good eyesight. Lens 2, that person is short-sighted. So we will try 4 and 5, which would be the glasses they might wear. 4 makes it worse. 5 makes it better. So you can do 5 beam, single beam, or 3 beam with our ray box. It's really easy for kids to see and understand because they have the picture. The teachers, it's very easy as well because they're told where to put the lenses. There we are. Okay, and that is our that's the laser ray kit, which teaches light and waves. The videos we have left to look at is the ring launcher, demonstration transformer, coils, the signal generator as well. We'll start with the ring launcher. Okay, this is your next video. Just got the message to say no sound, so sorry about that. Let's try it again.
Welcome to the Inspire range. The ring launcher is a self-contained kit. It demonstrates Faraday's law of electromagnetic induction and Lenz's law. The kit comprises the ring launcher base unit, the iron core, which is removable, an adjustment collar, which sets the height of rings when placed on the core. 3 rings are provided, 1 plastic, 1 aluminium, and 1 aluminium with a split. There is also a few coils of copper wire with a small lamp in circuit and a remote control unit. LED indicators show power on and the presence of the core. When the activation switch is pressed, a warning message is given and the activate status LED turns on. The remote control allows the operator to stand at a safe distance. When the remote button is pressed, the remote pulse and launch pulse LEDs illuminate briefly and a launch takes place. The coil with bulb is placed on the core and the remote control is used to activate the unit. Pressing the button on the remote activates the unit. From the fact that the bulb lights, we can tell that there is a transformer effect. The coil in the center is inducing current in the smaller coil, which illuminates the lamp. The solid aluminium ring can be fitted to the core. The plastic collar allows the user to adjust the launch height by simply sliding it up and down. As before, pressing on the remote control activates the unit. The second aluminium ring has a split, so it is incomplete. It's fitted to the core in the same way, and the unit is activated as before.
Step back when green light shows. Use remote to launch the ring now.
Using the remote control as before, the unit is activated. This time, nothing happened. Because the aluminium ring has a split, current cannot flow in a complete circle around it. The last ring is plastic and complete. As before, using the remote control, we activate the unit. You can see from the LEDs that the pulse happened. The plastic ring does not conduct electricity, so you cannot induce an electric current in it. The solid ring is fitted to the core. The adjustment collar raises it much further up the central coil. Activate the unit as before.
Green light shows. Use remote to launch the ring now.
The remote control again activates the unit. The ring jumps a shorter distance because it spends less time in the field that surrounds the coil. This is a safety feature in classrooms where you may need to restrict the height that the ring jumps. The ring launcher is one member of the Inspire family of products.
Yes, that was the ring launcher. I realised for the start of that video I was showing myself instead of the video, so I'm sorry about that. I had a couple of private messages and managed to get it changed over. As well as the laser ray kit, which I just demonstrated, the ring launcher is another piece of equipment I used to like to take to exhibitions. It grabs people's attention, apart from that Thunderbird style warning, which always makes people turn around. Seeing the ring fly in the air always brings a few people to the table. Kids really enjoy it, and if you have low ceilings, be careful because they will try to hit them. So we'll move on to our next video, which is the demonstration transformer coils.
The Inspire demonstration transformer provides illustration and investigation of the transformer principle, electromagnetic induction, and eddy currents. The demonstration transformer set comprises the base with U-core, I-core, and clamp, and a set of coils from 3 to 1800 turns. Available separately, the main substitute coils at 100 turns and 300 turns are required for the induction and motor experiments. The Powerpro transformer power supply is also required and available separately. The transformer power supply has special connectors on the 25 volt AC output, making it impossible to connect that voltage to standard coils. The other AC outputs are limited to 2 volts and 4 volts AC, so that no combination of coils can produce a dangerous voltage. The induction accessory set includes the 6-turn nail melting coil, 2 solid and 1 split aluminium ring, the solder trough, and some nails. The motor accessory set includes pole pieces, aluminium quadrants and disc, plus supports and pivots. Both accessory kits are available separately. Coils are fitted to the core and clamped. An AC supply is connected. The ratio of turns in this case is 300 to 600. We can monitor the input and output voltage using 2 AC voltmeters. The primary input is 4 volts. The secondary output is close to 8 volts in proportion to the turns ratio. For the induction experiments, it is traditional to use a mains-powered coil. This is available if required. The substitute mains coil has wings, which provide a high level of safety, preventing the fitting of an inappropriate coil, which might generate dangerous voltages. The 100-turn substitute coil is used for Thomson's jumping ring. The coil is fitted to the U-core and the I-core stands on top. An aluminium ring is placed over the core on top of the coil. The coil is connected to 25 volts and we switch on. Repeating with the split ring illustrates the need for a complete ring. In a complete ring, current can flow. The same 100-turn coil is used with a 6-turn nail melting coil. The core must be complete and clamped. A nail is fitted through the holes in the arms of the coil and clamped in position. .25 volts AC is applied to to the 100 turn coil, we switch on. In this experiment, 2 coils are connected in series and supplied with 8 volts DC. This provides a steady rather than an alternating magnetic field. The core is adapted using pole pieces, a support rod and pivot. The aluminium quadrant plate is fitted to the pivot. When the supply is switched on, displacing and releasing the quadrant illustrates the phenomenon of eddy current braking. Replace the plain quadrant with the slotted quadrant. Why does this quadrant behave differently? If the traditional mains coil is used, it also has wings to prevent dangerous combinations of coils being fitted to the core. The demonstration transformer is one member of the Inspire family of products.
So again, I'll just show you on the website. It's a very versatile bit of kit, and there's quite a few options for that one. Inspire transformer should be good enough to bring it up. Let's just open this one. Yeah, so when you're looking at the range, you can buy lots of bits individually. I would say if you haven't got anything, you need to get this one, which is the Inspire demonstration transformer with coils. And then if you wanted to do things like the break-in now experiment or the motor experiment, you'd buy the accessory sets to go with it. But yes, you will definitely need this one here. Accessories, you can buy the Inspire power supply. Documents, that's the video we just watched there. So we have one more video to watch, which is going to be the signal generator. And I'll go straight to playing it now.
The Inspire Powerpro signal generator supports a wide range of experiments in sound, vibration and waves. Sine, square and triangular waveforms are available from 1 Hz to 110 kHz in 5 decades. The output amplitude is variable up to 10 volts peak to peak, and can be attenuated for input to oscilloscopes and electronic circuits. A fixed level TTL signal is also provided over the same frequency range. Signals can be output from the internal speaker or connected to an external speaker. The auxiliary input accepts signals via an adapter from a microphone or music player and amplifies them. This works well for Rubin's tube. Connection to an oscilloscope provides visual illustration of the waveforms. and allows for measurement of frequency and amplitude. The low impedance output provides powerful drive for the vibration generator. The vibration generator accessories kit supports a range of demonstrations of wave phenomena. A silicone rubber cord under light tension can show standing waves at very low frequencies. A set of metal strips illustrates resonance at various frequencies. The frequency is continuously displayed in kilohertz. The Chladni plate offers an interesting investigation of resonance. Fitted to the vibration generator, the plate oscillates. Sprinkling dry sand onto the plate reveals the nodes and antinodes. Nodes are regions of the plate which are not moving. Vibrations in the panels of cars can be a problem. Students might investigate resonance in plates of other shapes. Amplitude modulation requires an input of up to 250 millivolts provided by an extra signal generator. The first signal generator provides a carrier frequency of about 500 Hertz. The second provides a low frequency signal, 1 or 2 Hertz, which modulates the carrier, changing its amplitude. Frequency modulation requires an input up to plus or minus 3 volts, again from the extra signal generator. The first signal generator in FM mode outputs a frequency at the center of the decade, about 550 Hertz. The second provides a low frequency signal from 1 to 10 kilohertz, which modulates the 500 Hertz carrier, this time changing the frequency. The Powerpro signal generator is one member of the Inspire family of products.
So that was the last of our pre-recorded videos to be watching. Hope you enjoyed them. I think there's some really good practicals and demonstrations there. I will just show you, there is a brochure for all Inspire products, which looks like this. As you've all attended the webinar, we'll get one of these sent out to you, or your local rep will have one of these sent out to you. It goes through majority of the products in the range, not quite all of them. And at the back it will say which product can teach which part of the syllabus. It's nearly loaded up. I'll just show you that part. Okay. I think it's the second from last page. Okay, the writing's still a little bit small, so we'll get these brochures sent out to you. But if you look at the dynamics card, for example, at the back it will have an AQA. It can be used to teach forces of motion, EdXL, topic 2, motion, momentum, OCR. It's a useful brochure, so we'll definitely get one sent out to all of you. Remember, until the end of the month, we are running our 10% discount as well. Not much time now, but 2 weeks to get your orders in if you want to get a guarantee of 10% off. If not, remember you can always contact your local rep and ask for a discount. So stop sharing this screen now. So they are the videos we looked at today. So if there's anything in particular you are interested in, you can type in either the name of the product or the product code into our website and you can re-watch the video. I'm conscious it might have been a bit of information overload today, jumping from video to video, but they're all there for you to watch back in your own time. If I was to do a demonstration of most of these products, I would tend to watch that video the day before I went to the customer, just to refresh my mind and make sure I hadn't forgotten anything. It's been a while since I've been out to do any on-site visits and demonstrations, but I have had a couple of requests recently since schools have opened. All the reps are available if you do need us for anything at all. Okay, yeah, these two slides just show everything in the Inspire range. Again, won't dwell on it, but there's quite a few things in there, including voltmeters, ammeters, some smaller stuff. The curve track, which goes with the dynamics car. If you get the dynamics car, I would recommend you get the curve track. Again, you have our website. Some people, we are SLS Select Education. If you type SLS into Google, you end up on the industrial website. Our website is actually www.sciencetoeducation.co.uk, or you can find that by typing Select Education into Google. A number of customer services who are always best if you're asking questions like stock levels or where's my order or ETA on an order. Tech support, I say we've got Donna and Kat who would have been answering your questions via the chat today if it had been working. Once again, sorry about that, but you can always email them direct, or as usual, if you contact your TSM, which could be me or say one of our 6 or 7 people who are over the UK, then we'll always try to answer your questions. And if we can't, then we tend to email Kat and Donna and ask for their help. I found out recently our new catalogue is going to be slightly delayed. We was expecting it to be out sort of mid to the end of April, but now it looks like it will be out roughly the first week of May. We'll make sure we run 1 or 2 more webinars just after it's out. One of them will be a catalogue launch, just to look at the new catalogue, new products, what's new, how to get the most out of your catalogue. And we'll do another one which will be more product related, similar to this, but we might try and do something other than physics next time, just to keep it balanced. Thank you to everyone for turning up today. It is actually exactly 3 o'clock, so we've had a 1-hour webinar. Usually I'd invite you to stay on and ask any questions, but since that's not possible, I'll end the webinar in the next 2 or 3 minutes, but please do email with any questions you have. Say we're here to help. We're all available and quite keen to leave the house as well, so if you need an on-site visit, let us know. I'm just going to check what messages I have from Kat and Donna. Yeah, okay, so there's nothing about the equipment. So I am going to end the webinar now. At some point there'll be, this recording will go on our website. The last couple of webinars, I promised it'd be done within a week. I didn't quite understand how much work went into it. So it will be available if you want to see it. And again, if you email your local rep, there'll probably be a YouTube link they can send you within about a week or two. And eventually there will be a webinar section on our website, which will show this and the previous webinars which we've hosted. So once again, thanks to everyone for coming, and hope to see you next time. Okay, bye.